welcome. It's Mr. Azar, obviously, and I'm here in Long Beach. And I'm going to teach you about wave action. Figured it would be a good idea to do that today since the beach is pretty quiet with the coronavirus outbreak. It's not that hot out, so there's not a lot of people here. On a side note, I'm going to throw in some extra reviews, so it'll be a good time. So I'm just going to stand this way for now, but feel free to look around. One of the things I want to just mention first is, actually if we look kind of right up here, what's going on. So where I'm walking right now, and if you want to look around, you'll see that there is a really flat sloped area. And so just as a reminder, we've learned about tides this year. And so ocean tides are controlled by the moon. And so right now is a much lower tide. And you can see that if you look down on the camera, you can see that the floor is pretty wet. This is where the water usually is. And so right now, the moon and the sun are at right angles from each other to the earth. And so we have a moment where it would be sort of either a neap tide, although I don't know what the moon status is right now, so I don't know if we're at a full moon or a quarter moon or something like that. But we're at least faced sort of at a right angle to the moon as far as the rotation of Earth goes. So the result is that we have low tide. The sun is pulling the water one way, the moon is pulling it the other way, and so yeah, we're kind of in a weird middle spot right here, and so that's why the water's so low. Remember, it's the gravity of the moon that is what gives us tides. It's about twice as strong as the sun's gravity, and so that is what gives us tides in the first place. So I'm going to start off with looking just at the water. And when you look at the water, there's a lot of things that are going on here. One, we talked about the concept of weathering, and weathering is just when something breaks. And so the sand here, which was different than if you remember my white sands video, and I could always post that or on YouTube, that was made out of gypsum. The sand here is made out of quartz, and it's much more resistant to weathering because of the hardness of the minerals being a lot higher. So, but every single time a wave crashes and hits, it's bringing with it other pieces of sand and rocks, and so it's constantly smashing into the sand that's here, and what it's doing is breaking it down even smaller into finer and finer grained sand. Oh, I guess the tide is coming up actually. So that's the weathering part. But now where's the wave erosion? Well, the erosion, remember, erosion means to move something. So where weathering broke it, well, how does it get moved? One, when the water smacks down, you watch the calm ocean behind me, the water smacks down, it hits the rock, it breaks the rocks, and then it pulls it back in. And that's something called longshore drift. So, have you ever been in the beach in the water, and where you start, you might be over here, you're swimming around, everything's great, you know, you're bobbing around waves, and then all of a sudden you get out of the water and you realize, I don't recognize any of the umbrellas that are over here. And so that's because the water has eroded you. It's drifted you down the beach. And so now you're gone. Now you're just like, you gotta go find your umbrella, and where, you know, where the soda is and the water, and you're hot. Now you're really cranky because you feel lost for a moment, so you got a little frustrated. But that's what longshore current is. So the longshore current is basically controlled by a bunch of things like ocean currents and things, but it's and the shape of the channel of the area. There's a bunch of factors that go into the direction that the current is going, but it's basically the idea that the water is, even though it's running backwards and forwards into and away from the beach line, it's also running across going down. There are a couple of ways you can figure that out from Google Earth, but we'll talk about that in a minute actually to figure out which way longshore drift is going. The second thing is, again, you'll notice that if you look around on the camera, you'll see just a whole bunch of sand and the water almost getting me, right? And so when we talked about sorted and rounded and angular and all that, when you come to a beach, you usually see sand. And so sand, and only sand, means that waves are really good at making things sorted. Sorted meaning separated by size. You don't see pebbles, cobbles, boulders, all these other things here. You just see sand, because the speed of the water plays a role on the sorting. anytime something can increase and decrease in speed, so like streams or ocean waves, wind, it's going to sort the sediments by size. Things like glaciers and gravity, they're not going to be able to do that because they basically just bulldoze everything. They just drop it off and there you go. But not this. So that's why we mostly sand. It has to do with the speed of the water. Now, if we left the beaches just kind of how they were, the beaches would get eroded. The sand would get taken away by the water and then there would be no beach left. So if you look behind me, and I'm going to turn in a second, or if you actually look behind me there, you'll see these rock outcrops. Now those are not real, or I should say they're not natural. People put those rocks there. Those are something called groins, or sometimes called jetties. There are other things like breakwaters. There's a few different versions of these, but the idea is pretty simple. To stop longshore drift, which is again the water just drifting one way and taking all the sand with it, they put those as basically barriers, like obstacles. So it's a wall. And so then as the water is running downstream and it comes up against the wall, it will force the water to slow down and the opposite of erosion will happen. What is the opposite? The opposite of erosion? It's a process called deposition. Erosion, think of a road. What do you do on a road? You drive, you travel, you move. So erode, think of a road. A road helps you go from one place to another. Erode means the stuff is gonna get taken and it's moving. Deposition is the opposite. Deposition means like if you go to the bank and deposit money, you're putting it down, you're putting it in your bank account. I'm gonna try to hop on this jetty in a minute. And so that's the purpose of this. As the longshore drift happens, the water's gonna run down and it's gonna hit these rocks and the water's gonna slow down. And on one side, it's going to actually deposit the material on one side. These are nice big boulders. Actually, another random thing too, look, if we look in this area, you can see that in addition to we have a lot of cool things going on here. One, the chemical weathering and the changes in color. That's chemical weathering, that's a chemical process. It's changing what the rock is on the outside. It's kind of like a rust or something like that. Similar type of idea. Wow, these used to not be so big when I was younger. They have put a lot nicer rocks out here. Alright, so now you can kind of see around me, the water's in front of me, and especially if you look kind of over here, I'll turn just so you can eventually start to watch the direction of the water. Even if you look around, you can sort of see they've tilted these a little bit. And so what happens is, as the water is moving, and the water is coming in, drifting down this way, it's kind of hitting these barriers. The water is slowing down on this side of the jetty, or the groin, and it's being deposited on this side because the water is slowing down. When water slows down, deposition is more dominant. When water moves faster, erosion is better, and more stuff will move away. So you have the deposition on this side. On this side, when the water kind of makes itself around this side, the water can pick up speed again, and it picks up more material. So you have deposition on one side, erosion on the other. But that's why you put another jetty, because then down there, the water will hit that jetty, or groin, it'll deposit it, and that keeps going. So that's why you see so many of these staggered. And I'll add a little shot on Google Earth, and I'll add a little video there so you can also see kind of how that works. So just to give a big overview, wave erosion is pretty straightforward. The ocean water comes in, it's abrasion that smacks into the other rocks and breaks it. Again, abrasion is like an abrasive. If you scrape yourself, your doctor would say you have an abrasion. So that's the water coming in. The direction that the water is traveling over the entire beach, if you were to watch it for a long period of time, if you're on a boat and you're just kind of bobbing around and how you end up from a different place, that is called longshore current. And then all the stuff here is sand because water sorts the stuff, and from the constant abrasion, it's also rounding the little particles. So pieces of sand are usually generally rounded the more that they get weathered. Lastly, the purpose of something like a jetty or a groin or a breakwater, which they don't have here, but it's basically like a wall. If you ever use like a Brita pitcher, you'll see that in the top where you pour the water, sometimes they have like a little thing that sticks out. That's so that the water slows down as it goes around, so it doesn't just splash over. That's what that basically a breakwater is. And so on one side, you'll have an erosional area. How do you know that there's erosion? There's more stuff missing on this side. On this side, you know deposition is happening because there's more sand on one side than the other. At a time like this when the tide is actually really low, unfortunately it's not the best time to really get a good idea. I can see from my vantage point that this side is a little lower and this side's a little higher, but I don't know if you can see that on the camera. So, I mean, I'll turn around too. But that's how you would know. This is where the erosion is going, and actually, if you want to rewind the camera and look over there, you can actually see the water kind of slowing down. It's getting eroded from under there in some places, and right next to it, closer to the jetty, you can actually see where the sand is actually built up as the water goes around. Over here, you can kind of see and sort of the opposite. And so that's wave erosion in 11 minutes. Thanks for watching. I hope you enjoyed it and in 2D. And if you're watching this as a YouTube version, I hope you enjoyed the 360-degree model. See you next time.